In this video, we want to consider exceptions to the ways that we have described for drawing Lewis dot structures. There are three main ways that we can have exceptions to the so-called octet rules for drawing Lewis dot structures. The first is there are molecules with an odd number of electrons. While this is not a particularly stable situation in many cases, there are some examples of this. Second of all, there are molecules where certain atoms can have less than an octet if we have a situation that involves relatively electropositive atoms. And then finally, we have molecules that can have more than 8 valence electrons. This involves atoms that are central atoms, typically in the third period or greater on the periodic table. As an example of a molecule that has an odd number of electrons, there are three commonly cited examples: chlorine dioxide, nitrogen monoxide, and nitrogen dioxide. For us to consider nitrogen dioxide, there are 5 electrons from the single nitrogen atom, but there are 12 electrons from the 2 oxygen atoms for a total of 17 electrons in the valence shells for these atoms, so hence an odd number of electrons. If we draw our Lewis dot structure following the rules that we have established, we end up having the final electron go to the central nitrogen atom, and unfortunately this violates the octet for this particular nitrogen atom. You'll notice that this Lewis dot structure would also require another resonance structure in which the double bond is moved to the other oxygen. The crucial thing is this is a relatively reactive molecule and is a component in smog. It is the brown haze that is often observed in the smog of major urban areas, and is quite reactive towards other molecules, so it's not a particularly stable molecule. As an example of some compounds that violate the octet rule for the central atom, we can consider group 1A, 2A, and 3A hydrogen-containing compounds. In this case, the hydrogen turns out to be the more electronegative atom, so it turns out to be the terminal atom, and the other atom, the lithium or the beryllium or the boron, turns out to be the central atom. In the case of lithium and beryllium, it's possible to argue that these are significantly ionic type compounds, and therefore drawing Lewis dot structures is not quite appropriate, but there is certainly some covalent character associated with the bonds in these molecules. But clearly we have situations where we would have less than 8 electrons for these 2 elements in these particular molecules. The most often cited example is something like BH3. In this particular case, the Lewis dot structure would be 2 electrons short of an octet for boron. Turns out boron is a relatively special situation, and turns out to be forms a whole variety of compounds where the boron is able to form bonds to other molecules, and certainly not a simple situation. So, in the case of beryllium hydride, if we draw our Lewis dot structure, we would have 2 electrons from the beryllium, an additional 2 electrons from the 2 hydrogens for a total of only 4 electrons. So we draw our Lewis dot structure and its skeleton structure, and by doing that, we have used up all of our electrons, so therefore beryllium ends up having 4 electrons short of the octet. This is just a consequence of the degree of ionic character in this particular molecule. And then finally, we can consider compounds that have central atoms that are in the 3rd period or greater. In this case, the elements can violate the octet rule by having more than 8 electrons. This is a consequence of the presence of the d subshell orbitals that are available to form bonds. So it turns out that the octet rule is not a hard and fast rule in this case. So these are 3 commonly cited examples: PF5, xenon tetrafluoride. While xenon is a noble gas, it is pretty far down in the column for the noble gases, and in fact it is possible to make certain compounds with these very large noble gases when we have especially electronegative atoms attached to it. And then finally we have sulfur tetrafluoride. This is the Lewis dot structure that you would get if you follow the rules. The extra pair of electrons after satisfying all the octets should go to the central atom, so we end up having a total of 10 electrons on the sulfur. This has consequences in terms of the shape of this molecule. So